Okay, last two problems from our 151 Fall 2010 first exam. We have a jet acceleration given, a time given. So let's go ahead and highlight some of these. There's our acceleration. There's a time. Okay. Initial phase. So then we've got another time. 12 seconds. And a velocity. Acceleration of the jet during the second part of the time's takeoff. So this should remind you of problems that we worked in two parts. So we will have to go like two constant acceleration equations. So let's work the first one. So here's part one. We know, let's see, I'm going to say we start at the origin. We don't know how far we went. We're taking off, so the initial velocity is 0. We know acceleration is 3.5 seconds, and we know delta t is equal to 5.7 seconds. It should be meters per second squared, and that should be seconds. Okay, we don't know a final velocity. Okay, so again we have two unknowns here. We can solve for both of them, but we really only need to solve for the final velocity. It does not matter how far it went in that first part, but we are going to need to know the final velocity of this first portion of the problem to work out an acceleration for the second portion of the problem. Alright, so let's find V2. We don't care about S2. Okay, so what equations do we have? We have one that says V2 equals V1 plus AT. That'll work. Don't forget about that one. Okay, so that's going to be equal to 0 plus 3.5 times 5.7. Okay, so come over here, get that number. 3.5 times 5.7. And let's type it in right. 3.5 times 5.7. 19.95. Meters per second. Alright, so for part two, we're going to set, again, we don't care anything about distance. So we'll reset S2 back to 0. So we're really starting at a different, this part, moving our origin over. That's okay. We're going to call V2 is equal to that number. Takeoff speed, V3, 81.3 meters per second. Delta T, 12 seconds. We don't care what S3 is. We want to find acceleration. Okay, so again, you have to have 4 known values, so we know those 4 values. Look for an equation that has A in it. And it actually, the same equation. V3 equals V2 plus A, we'll call it 23, so we're going from 2 to 3, times time from 2 to 3. Okay, so that's our 19.95, 81.3, plus A23 times 12. Okay, a little algebra. Now let's see, 81.3 minus 19.95. That quantity divided by 12 is going to give us 5.11. Units are going to be meters per second per second. Meters per second squared. Last problem. Object starts with a velocity, given ij notation, undergoes constant acceleration, ij notation. After 4 seconds, how far is it from where it started? Okay. Hopefully you remember working some of the 2D motion problems. We said that 2D motion, constant acceleration. Okay, so here's our constant acceleration. Can be worked as two one-dimensional problems. So let's work it in x and y, find out those values, and then combine them at the end. Okay. So we have a general equation, S2 equals S1 plus V1t plus 1/2 AT squared, because we know information about acceleration, velocity, given the velocity up there, the acceleration up here. We're going to use starting at the origin, so we know our initial position, and we can find our final position because we know the time, given time. Alright, so x final is going to be 0 plus the velocity in x is 12 times 4. These are 4 seconds. Plus 1/2 our acceleration in x minus 2 times 4 squared. We'll go ahead and write out the y equation. Start at 0. Y is going to be minus 15 times 4. Y acceleration is going to be plus 6. 4 squared. Alright, let's calculate our x is 12 times 4 plus 0.5 times minus 2 times 4 squared. Double check our numbers. Okay, it looks like 32. It's going to be units of feet. This is going to be 0. Not sure why I did that. Minus 15 times 4 plus 0.5 times 6 times 4 squared. It's going to be a minus 12 feet. Okay. Cannot just add these two up. That's 32 feet in the x minus 12 in the y. So we use xy coordinate system. Okay, we had 12 down and 32 over. So we're looking for that distance right there. So d is going to be square root 32 squared plus 12 squared. Okay, square root 32 squared plus 12 squared. 34.2. Okay, so we have worked through the entire exam now. I would encourage you to then go back and check all the problems to make sure you've got numbers that sort of make sense. So let me do that real quickly here. how far is it from where it started? Okay, so we have units of feet, and we have a number that's the distance. Okay, again, rounded to 3 significant figures. Let's see, acceleration during takeoff, meters per second squared is the correct unit for acceleration. Okay, 3 significant figures. Let's see, how much time? So we got time in seconds, and 99.4 is 3 sig figs. Average velocity, so meters per second. Remember when I worked through this one, I actually put my delta S in there, so checking units would have caught that. Meters per second, 3 sig figs. Let's see, that looks correct. Determine the angle theta. So hopefully it's going to be in the first quadrant. The way we worked it out, 52.3 degrees. Could have been 2 significant digits would have been fine there. Determine the angle, 28.5. Again, we talked about that being reasonable based on a drawing to scale. Volume of a football. So we're meters cubed, we're getting bigger. Okay, so 30 cubic meters. And magnitude of the displacement vector. So we start out with feet, so we have units of feet there. And eddies was unit there. We wanted in an IJ form. So we got down in the Y and positive in the X. Not sure where that 5 came from. Let's just typed in as I was doing something else, I think. 10.1 meters and 2 rods. Rod was 16.5 feet. So 2 rods, about 32 feet. So 10 meters sounds pretty good for that. 33 feet. Okay, we'll wrap it up there.